there something near your microphone, maybe?
No. Me.
Right.
Yeah, and I wish that I really enjoy the videos, but I wish that he was using Excel.
Yeah, that part was, I didn't like that part. And I don't know if it's in the next lesson or it was in the last lesson, but he goes back and forth. He'll do Excel and then he'll do the SPSS, but in the other lesson he didn't do that.
Yeah, and then I'm like,
well, and these were recorded like back in 2013 or 14 when maybe it was just as these online classes were getting going and we don't do the SPSS.
Yeah.
For feedback, you know, when we do the class review to talk about that, so they're getting that information back to them.
Yeah, no, that's good. That's a good point. We'll have to bring that up. So, alrighty, let's get started. So, let's get to the.
Got to download 2 data sets and make sure you have the T link.
Yeah, and for some reason, every time I've tried to download something, it just keeps freezing up my computer. So I'm very frustrated.
See, that's what I had the last time, and
right.
I felt like I fell behind in what we were discussing. Okay.
Hey, by the way, how do I sound? Do I sound okay now?
Yeah.
You sound, yes, you're fine now.
Okay, yeah, good.
I'm going to be right back. I'm going to get my laptop. I'm freezing in and out.
Excellent.
Okay, so.
So when we copy and paste this, oh shoot, we're doing no, okay, paired sample t-test tab, right?
You're
then
under what?
And then the first column is the group 2, the after group.
Let's see.
Right, so let's just.
All right.
We have a set of paired data and let D, X after, no hypothesis, alternative. All right, we know all that. Deviation is not known. Jordan collects a sample size of 9 and computes 2.2 and the standard deviation of 3.3. So what's the value of the test statistic? So.
So it looks to me like the answer is in all that information in the question. I don't think we need to use our QIP spreadsheet yet.
No, you just have to use the T formula.
I'm sorry.
What's the T formula again? I forget it.
So it's D bar minus the whatever the U, whatever that's called.
Mu.
Divided by the standard definition of deviation of the difference divided by the square root of the sample.
Okay.
Because that sounds simple.
So that's going to be 2.2 minus 0
Yep.
Yep.
Okay. over 3.3 divided by the square root of 9.
Yep.
Okay. Oh, I gotta grab my calculator.
Is it 2?
I was just going to say I come up with 2, but that doesn't seem like it would be right. But
That's what I got.
okay.
Yeah, just, yeah,
Okay.
I think 2.
Okay. Probability of obtaining a test statistic greater than Jordan's test statistic is 0.04. Use the probability to determine the p-value for Jordan's hypothesis test. Round to 3 decimal places. So the p-value. So the p-value we're using, because we're using the t distribution applet.
I don't even think you need that. I think if you take the test statistic of 0.0403 and then you add another tail to it, because his hypothesis is all about, it's about equality. It's not about greater or less than. So I think you double test statistic, which would make 0.08, maybe 0.081.
Yeah, I got 0.081.
Did my logic make sense then?
Yeah.
If James got the right thing, yeah.
Yeah. So you take your test statistic and you double it.
You double it, yeah. I seem to recall from the QIP sheet, when you're putting in the type of test, either greater than or less than or not equal to, when you put in not equal to, the p-value doubles.
If it's one-sided.
If it was one-sided, yeah.
One tail,
So,
yeah.
0.081.
Sorry, I missed it. How do we do this problem? I'm really lost.
Yeah, no, it's and I think I'm just going by memory, and James will probably have to fill me in a little bit. I recall from looking at the quantitative inference procedure spreadsheet on Excel, which I've opened up over here, and I put in the columns for the next series of questions already. In cell F11, if something is one-tailed, it's either greater to or less than, so the p-value would be a certain number. In this case, question 4 says the p-value is 0.0403, and then I changed the type of test to not equal to, and it doubled the p-value. So I'm thinking that we just double this p-value in the question, because we're taking a one-tailed test, whether it's greater or less than, and we're putting 2 tails on it, which automatically makes the p-value twice that. Nikki, was that worse? That sounds like it was worse.
I don't know the input. What inputs do we put in the inference?
Oh, good.
one.
I didn't do any input on this question at all.
Oh.
I recalled something in one of Sister Lemon's videos about doubling, about, you know, if something has a one tail, whether it's a tail on the left or a tail on the right, for a greater to or a less than hypothesis test. But if it's a not equal to, then you use two tails.
Okay.
That's why I'm just thinking it's two tail. You're doubling a tail. If one t value is this tail on this side, or one t value is this tail on this side, then a not equal would have to be both tails.
Okay.
Did that make any more sense? And because you know, what works out in my head might not work out of my mouth very well.
I'm just trying to set up the problem. That's
Right.
Are we on question 5 still, or have we moved on?
Oh no, that was question 4.
Right.
Are we okay with question 4?
Okay, yeah.
Oh, okay.
Yeah, there we go. Okay.
Okay. So use the data file chapter 12 data A1 to answer the next 6 questions. Perform a paired test in, well, it says SPSS. Be sure that the test does group 1 minus group 2. Use the null hypothesis. Okay. So the 12 data. 12 data A. Okay. 1 minus.
All right, there it goes.
Would question 5 be the t value, the 0.407?
Yes, that's what I think.
I got.
Or negative 0.407, depending on how you put the data in.
Well, it says to do it. It says to do it specifically. Be sure that test group 1 minus group 2.
Okay, then it's not the negative, it's the positive.
Okay.
I put my data incorrect.
So okay.
No.
What did we put in the quantitative, in the QIP? Let me just say that.
Yeah.
In the QIP, did we put group 1 in column A and group 2 in column B?
Yeah.
Okay. All right.
The colored sample t-test, right?
Right. Yes. Now I'm still working with a laptop with one screen, so I'm all going back and forth.
Right.
Okay.
So you put. Yeah, because it wanted. Well, I mean, I just did it as. Say.
What is the test statistic?
That's just the t.
Okay, hold on. I keep pulling up the wrong screen. There we go. QIP. I have all these Excel sheets. So I have 0.407.
Yep.
Yeah, that's what I.
Yep.
Okay. Okay. The p-value then.
Is everybody up to speed on the t-value? Everybody sees that?
Yeah.
The p-value 0.656.
What's your confidence level at?
Let's see.
I got 0.689
I have
for
confidence.
the p.
I have confidence level at 0.95. What are we supposed to be?
0.90.
Okay. That's what
I
okay.
don't have anything yet.
0.90.
Spreadsheet is.
So my p-value is 0.656. Hold on. Hold on. I've got that whole section messed up, I think. Hold on.
Okay.
I'm seeing that. Let's see. All right. Yeah, type of test not equal to. And oops. No hypothesis 0. Okay.
All right. Can
Okay, so then when I had my confidence level as 0.90, null hypothesis is 0, and type of test not equal to, then my p-value was 0.689.
Mm-hmm.
Yep.
That's what I got.
Okay.
And actually, confidence level didn't change the p-value.
no, it doesn't.
I just hadn't gotten it in there right in the first place.
Okay, well, and I don't either then.
What do you have?
It has nothing.
Oh.
So the confidence level is 0.90.
Yeah.
It's 90. Okay.
Well, it's not relevant to the question.
Well, it's relevant to the information though, because the level of significance is 0.10.
Yeah.
So might as well just have the information in there.
That's what you're saying, yeah.
And that's given me a confidence level of negative 100.882.
Yeah, that's right. But look at the p. What's your p-value?
Oh, 0.688.
Yep. Be
So
0.689.
689, yeah. So I don't even know what the question was asking. P-value.
It was asking for the p-value.
Good heavens. It's just hard, it's just difficult for me with all these spreadsheets and going back and forth and stuff. What's the correct decision based on this evidence? So
This is the screen I use, so I can't even imagine not using.
Oh my gosh.
Yeah.
no, I'm on a laptop screen.
I wouldn't be able to do it.
Yeah. So that's why it takes Joan and I so long, because we're like
689.
It's like 40 inches big.
So the level of significance is 0.10, and our answer is 0.689.
So
Yep.
we
We
reject the null hypothesis because it's not equal to, right?
Mm-hmm.
it's
Well,
the
no.
We said that they,
this is the if the p is lower than the level of significance.
Yeah, see, it looks to me like if the p is higher than the level of significance. Oh, wait a second. The p is lower than the level of significance. So if the p is low, reject the HO.
Right.
So would it be fail to reject then?
No, because the p-value is lower than the level of significance. The level of significance is 0.10, and this level of significance is 0.689. So it's higher than the.
this is higher, not lower.
So it's higher than the level of
So if
significance.
it's high, we keep the guy.
That's right. So we fail to reject the null hypothesis.
Oh, yeah, yeah.
Such a weird way to phrase things.
Yeah.
So yeah.
So which one is it?
The first
Fail.
fail to reject.
Fail to reject.
Right. Because the p-value is higher than the level of significance.
I just remember from the first one, P is low, reject the null.
And P is high, reject the guy.
Right.
No. If P is high, keep the guy.
Keep the guy.
Remember, Sister
yeah,
Lemon uses
yeah.
that to voice inflection.
So when you keep, you fail to reject, which is so
Yeah.
ridiculous.
Yeah.
Dumb.
I have
It's
to
like
point back to the innocent or guilty. All you did was prove that you couldn't prove them guilty, but you didn't prove them.
Doesn't necessarily make them innocent.
Yeah. So they could be guilty but got off scot-free.
So suppose your alternative hypothesis is instead it's greater than 0. What is the correct decision based on this evidence?
So I got to go back and go greater than. And my p-value then is 0.344, and I'm still in the same situation. Is it still higher than my level of significance?
Yeah, if it's higher, that means we haven't proven anything.
Right.
So,
Well, they're just talking about kind of the layman's terms here. So are we saying we have sufficient evidence that the mean of difference is greater than 0?
No, I think we have insignificant evidence that the mean of the differences is greater than 0. So insufficient evidence.
it's, yeah, one of the first two is insufficient.
The insufficient evidence that the mean, yeah, because if you fail to reject, it's insufficient.
And we never said that it was equal to 0. We always said that it was greater.
Right.
Greater.
Yeah.
So I say the second one.
Yeah.
Yep.
Second one.
Okay, now we're going to use the second set of data.
This is the B data. Oh, and how does it need to be? Sure, the test does group 1 minus group 2 again, so it's the same thing.
Might be, oh, it's coming up.
What is greater, the number or the degrees of freedom?
The number, right?
The number is 27. The degrees of freedom is 19.
It's telling me my B data is corrupt.
How did I get number 22?
That's what I got too.
For
For
what? For what?
The
For the
N-
number.
And on the QIP, I got 22.
Yep, 22. Sorry, I was looking at.
Oh, okay.
It starts on 6. So
Okay.
that's why I got confused. So the number is 22 and the DF is 21.
Yeah, so N is bigger,
And it's bigger.
right?
Yep.
Yeah.
Yes.
I can say 22 is higher than 21. I can
Yeah.
say that with 100% confidence.
Okay, sorry, I'm catching up. My B data was corrupt. I had to download it again.
Okay. Got
I
it.
hate that. I'm sorry. And then the
I don't mean for you guys to feel my pain. Okay. And so all of your conversation I totally missed because I was trying to get this.
well, when you put them in, you put your variables in, right? And then it comes up that the number is 22.
Okay.
And the
Gotta
degrees
get
of freedom is 21. So N is greater than DF for that.
My N is 21 and my DF is 20.
You're missing something. That
Okay.
Oh, did
You're
you
missing
pick
some
the
numbers?
set?
look on your differences and make sure that that each one is calculated. 'Cause I had that-
Oh, okay.
I
Yeah,
missed the
one.
number.
Okay. Yeah, let me go back.
You just have to copy the thing down.
To make sure and get the uncorrupted data. Okay, let's see here. Are you serious? I gotta shut down Excel and reopen it. I can't believe this. Close all my windows.
And like it's not stressful enough, and then you're at the mercy of computers.
Okay. Let me see if I can get. Okay, go away. Data A, data B. Okay, I got data B now. Okay, hold on. 30 through 8. C, B. Okay, so my N is 22 and my DF is 21.
Correct. Okay.
All right, let me get
So then the answer is N is greater than DF.
which
Yep.
is N or DF, my N.
For question 9.
Yes.
Listen to me.
The p-value,
I 0.00121 or 122, I guess. If we're only going out to 3, I don't even know how many we go out, but
0.001, right? It would be the
yeah, 0.001 because we go to
okay. Once again, I don't have my top set up right because I was messing with everything.
So the confidence would be the 0.99,
Okay, right,
and then the null would be 0,
right.
and then the type of test would be not equal to.
Okay, not equal to. All righty, thank you very much. So p-value 0.001.
correct.
Yeah.
Okay, thank you guys.
Yeah, no. So what decision do you make? So the p-value is 0.001 and the level of significance is 0.01. So the p-value is less than. So
P is low, reject the hoe.
we reject it.
That's it. I agree.
Okay. So you decide to try another alternative hypothesis because you're a glutton for punishment. This time you use
Greater than.
greater than 0 and you keep the same level of significance.
Greater than. It even went smaller. It went 0.000. I mean, 0.0.
Now it's really less than 1. You know what I mean? It's the smallest. And I know there was something very specific about that. So what does this say?
Did the p-value increase or decrease?
So it decreased.
It decreased, yeah.
So you're still rejecting it because it's still low. For 13.
Yeah.
I concur.
Yes.
So low, it's still lower because it already did.
Yeah.
Based on your response from the previous question, which conclusion do you make?
So if
This would be the sufficient, right?
If we reject, I always have to go back. So if we reject, we have sufficient.
So it's either 1 or 3. There is a mean difference or there is no mean difference.
Well, if it's a less than a 0, there's really no mean difference, right? Like, am I
Yeah.
thinking that right?
Yeah. It's also, I think since we're rejecting, we have proven that they're not equal. Because remember, all null hypotheses are statements of equality.
Right.
And if we've disproven the equality, that means that there's inequality or that there's a difference. So I think it would have to be the third one. We have sufficient evidence that there is a difference to the means, or a difference between the means of the two groups, or between the means between the two groups.
We have sufficient evidence that there is a mean difference between the two groups.
Okay. Sorry, I'm back. I was distracted.
That's fine. That's fine. We're just
I had an employee of mine go AWOL today, and so he finally responded to me.
You found him, I hope.
Yeah. Anyway, sorry. I had to respond back to him. What number are we on?
14.
We're on
Okay.
14.
So do we reject the null on 13?
Yes.
Good. All right.
We rejected 13. We rejected the null.
And so now we're going between in 14, the first choice or the third choice. We're leaning toward the third, but we're still talking through it.
I like number 3.
Okay. That's where we were going.
That's where we're going.
Okay. So as we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
At the bottom one, I thought.
It's
Well, what determines the p-value?
the probability. Well, the p-value is the probability, right? So,
You know, I think it's the direction of the tails, isn't it?
Are we on 15?
15, yeah.
Yeah.
So the p value is if you have a t score or a z score that's in one of the two tails. And I don't think we.
It all depends on what the hypothesis is, on where the p-value is true or not, I guess is the right way to say it, or if the probability that a hypothesis is true.
right.
So,
And which alternative gives the smallest p-value?
I think it's the greater than.
The greater than's the fourth one, right?
Yeah.
Mhm.
That's the one that I was first thinking.
Because if it's greater than what you're thinking, your p-value, so right? Well, and I just know in the one we just did, when we made it greater than, the p-value got smaller. So
Yeah.
really, I'm just
That's
cheap.
where I got that from too.
That's what I'm thinking. But y'all know I'm not the expert on any of this.
None of us are.
Oh, some more than others. So what do you think, Ed?
I can't get myself away from the idea that since the p-value is based on the alternative hypothesis, that we just got through proving in that last question that we rejected the null. Gosh, you know what? I'm thinking there's not enough information here. and I'm not very good at juggling too many bowling pins, but
Okay.
I think there's bowling pins missing.
And what do you think, James?
yeah, I think there's not enough information. Depends on the problem.
That's a whole new thing to think about. And this may have been how, like where Joan and I were going, well, we just saw that it went lower, but only necessarily in that problem, not in all problems.
True.
You know, and so my mind took me directly there, which is why it's so great that they put that question immediately after that, because you go with what you just were familiar with instead of maybe thinking it through, realizing, okay, this is not just about this question. This is about all
In general.
problems. Yes.
Do we think it's not enough information? Is that the consensus now?
Where are you thinking, Nikki?
I think so too, because it seems like, it seems like if like the number of data were to be like the above 30, that you might have like a different like p-values, you know, with the greater than and less than and stuff.
Okay.
I think it's not enough information.
Okay.
Okay.
This one might be one that maybe Sister Lemon can maybe explain to us kind of better of why there isn't enough information, because I think it's not enough information. It depends on the problem, but I can't articulate why I feel or know that. And so
I think I agree. I'm not sure why either.
because I think the p-value, it all depends on your sample size too, right? And it depends on there's different factors that weigh into what your p-value is going to be. So for instance, if I just take, some of these away, my p-value changes. If I take some of the samples away.
Yeah.
Right.
So there's different factors that go into it.
Which is, I think, the clue of the question in general.
Yeah.
It's telling you not about this particular question or this particular problem. And in general, like you said, there's so many various pieces, moving parts.
Yeah. All right. Well, hopefully we didn't lead you astray on that one. We'll find out.
Find out. So determine the 95% confidence interval for the mean difference between the two groups using group 1 minus 2. Input your answers here. So what is the point estimate for the 95% confidence interval? Well, the point estimate is the difference, the sample mean of the difference.
I believe that is correct.
So then that would be 11.955.
Yep.
Yes. 11. Yeah.
0.96.
Well, is it 2 decimals? What does it say?
No, it actually
Doesn't
doesn't say, so I think we should just put the entire answer in, since it is only 3 decimals.
955.
Okay.
11.955 with the mean.
Mm-hmm.
And do you see what that is, Nikki, on the spreadsheet?
Yeah, that's the differences, right?
The difference, yeah, it says mean and it has the differences, variable 1, variable 2 differences.
Yeah.
Okay. And then it wants the standard error of, what's the next question?
The margin of error.
Error.
3.199.
I think this is the one where
Isn't it J23 minus I23?
yeah, that's what I'm thinking. So
Right.
I worked with her last night. She made in K column, she made a formula for that to she goes, I'm just going to make a formula for it. And then I have it there. I'm like, cool, I'm doing that too.
And that's for the margin of error.
So that's a
It's different than the error of the mean. Standard error of the mean is not the same.
Oh, okay.
So 13.304,
no, I don't think so.
totally wrong. Or then you divide it by 2. That's what you do.
I got 6.6385.
I got 6.652.
I got 6.652.
Okay. So I did the 18.607 minus 5.303, got my answer, divided it by 2.
Yep.
Because it's 2 margins of it. It's 2 it's 2, you know what I mean? 2 intervals.
2 standard deviations.
Yeah, that's what it is. I've got all these terms in my head swimming around.
I know it drives me crazy. In fact, right when my head hits the pillow and I should be falling asleep, all of this junk starts going through my head.
So what was the answer for that one?
6.652.
Do you know how to get that answer?
Well, I got something super close, but it wasn't exactly it.
What's your what's your confidence level or interval numbers?
Mine's 5.303 and 18.607.
Yeah, so if you subtract 18.607 by the 5.303 and then divide that by 2. So I don't know if if you just do it in Excel, you can make a quick little margin of error.
Oh, now I got it. I must have entered a wrong number last time.
Yeah, there. Good. I'm glad you asked.
There
So
we
we're
go.
6.652.
Oh, now it wants the lower bound. 5.303.
Yep.
And the upper bound, 18.607.
Why won't my Excel let me do the calculation?
Now for question 4, that was 0.081 for that one, right?
0.081. Yeah.
Yeah.
Okay, question 3. I have 2.
All right.
Is it 2 or is it 2.2?
2.
Okay, somewhere I messed that up. Okay.
The D bar was 2.
Yeah. I thought the D bar was 2.2.
That's what I meant to say. Sorry. Sorry.
Okay. All right. I'm just making sure I get all my 2's right. I don't want any extras going on if I don't need them.
Sorry about that. All right. I'm going to.
And I'm sorry, I was trying to get my Excel thing. So 17 is, what did we decide?
6.652.
6.252?
6.652.
52. Okay, that's what my formula came out to then. So I just wanted to check that. For some reason, it wasn't letting me doing it. So 652.
Did you get 18, Joan?
And then the lower bound is 5.
I got 100%.
Oh, good. Yeah, lower bound is 5.303.
Yep, 5.303. Upper
And then-
bound is 18.607.
607.
18.607.
100%. Okay, at least I typed everything in right this time.
I think we did well.
Perfect.
Yeah.
And you know, we just need to talk it through.
Yeah.
Oh wait, I missed one.
Which one did you miss?
Question 5. Oh, because I put the 0.407. That's why. Put negative 0.407.
Oh, yeah, it's just 0.407.
All right. Let me write all these down.
I can stay with you, Joan, if you need.
Okay.
So sweet for doing that.
See you later.
Thank you. I appreciate it. Thanks, everybody. Have a good week. We'll see you Thursday.
Bye.
See you guys.
Guys, bye.
Bye-bye.
Bye.
Bye. Okay, so Joan, let's see.